Hi, how's going on? Welcome to another video, and in this video we are going to learn how to create this. Create a web app which directly reads from the user webcam and do whatever operation you want to. So as in this example, I am doing the face detection example, but you can do whatever you want to. So let's directly jump into the video. So talking of requirements, we are going to install a library called streamlit webrtc, and we are going to use that for all of this. So we'll say pip install streamlit -webrtc. I will link the command as it is in down description. Another we are going to use is streamlit itself, so we'll say pip install streamlit. And other than that, some are obvious, like we are going to use numpy and opencv python for doing the face detection. So I'll stop this right over here. Now let's create a blank directory. I'll just call this video and I'll get inside it, and let's create a blank python script. You can call this whatever you want to, but I'll say app.py, and open this whatever text editor you use. So there we go. So let's first import the library. So we'll say from streamlit_webrtc import webrtc streamer. So for now, I'll just show you how you can make very simple video streaming platform, and after that we are going to use the frames to detect the face from that, right? Very simple. Just have to say from streamlit webrtc import webrtc streamer, and you just have to call the function. You just say webrtc streamer and give key equals to anything. Let's give key itself. Now to run this, you have to open the terminal in the same directory. Make sure you open it in the same directory, either by just using the cd command or whatever. Now to run this, you have to say streamlit run app.py, whatever name you have given, streamlit run app.py in my case. So once I hit enter over here, a new browser window will open, and I just have to click on start. There you go. You see yourself in the screen by using your webcam. Now we are going to use this stream to process each and every frame and then output that processed frame to the user or to the browser. So how to do that? Very easy and very straightforward. Just have to create a class with whatever name you want to give. Let's just call this very obvious one, video processor. I'll just call this video processor, and in this you have to define a function called receive, recv, and these are the arguments, parameters you have to specify. First one is self, obviously, and the other one is frame which we are going to use, which we are going to receive. The name itself, clear itself. So you just have to say for now let's just return frame. We will process this, return this frame processed one. Now to specify this, that we are processing every frame by using video processor, you have to come back in video webrtc streamer, and there is a parameter called video processor factory, and initially it is none, but we have to give it video processor, which we have defined over here. So now every frame will be processed by using this class called video processor, and this is going to receive the frame in this receive function, and after this it returns it. Now this frame is not of numpy array or the array format. So to convert this, I'll call this frm is equals to frame dot to nd array. Very straightforward, and you have to give the format. So remember opencv reads the frame in bgr format, so we'll do the same, bgr24. So that's it. Now you have the frm, you just apply whatever you want to. So now I'm going to apply the face detection technique on frm, but you can do whatever you want to, but still the work is not completed. This is our frm. We are going to process this frm, but we are returning the frame. But we can't directly say that return frm, because this expects it to be in AV library format. So we'll import AV also over here to convert this num array to AV format. So for that you just have to say av.videoframe.from nd array. That's it. You just pass this frm, and once again you have to give the format, which is not RGB but BGR. That's it. Now apply whatever you want to. Now as I said, we are going to do the face detection technique, so I'll just import cv2 over here, and we need a har cascade file for that. For that you just have to search for har cascade. It must be in your in the home, actually, wherever you have installed. So in my case it's in Anaconda 3. Wherever you have installed the opencv, you just have to search for har cascade file, har cascade. You can also get it from internet. I will also upload it with the code, but you don't have to do this step if you get this file from anywhere else. So we need a file called frontal face, which I see over here. So I'll just copy this file and take it in the same directory, which is called har cascade frontal face default.xml. I've created very detailed tutorial for detecting the face, so I'll just be very quick for detecting the face, since this video is more of showing you how you can process each and every frame. So for face detection, we'll create a cascade object. So we'll say cv2.cascade classifier, and in that you just have to pass the file which is in the same directory, which is this cascade frontal face default.xml. Now we are going to use this cascade to detect for faces. So we'll say faces is equals to cascade.detect multiscale, and in this you have to pass the FRM, but that needs to be in grayscale. So we'll say very easy cv2.cvt color and pass this FRM, and we are going to convert it to BGR, cv2.color underscore BGR to gray. And there are other two arguments you have to pass is scale factor and minimum neighbors. The optimal values are 1.1 and 3, I guess. Now we just we got the faces, we got the result in the faces, so we'll iterate in it. This is the tuple of four values, x, y, width and height. So x, y, w and h in faces, we'll iterate in it. We are going to say cv2 dot, we'll draw the rectangle on the FRM, of course. Point 1 will be x comma y, of course, and x plus w, y plus h, width plus height, remember. And color we are going to give green, BGR. That's it. Now width I'll give 3. I guess this is enough for the face detection, and let's once again run this by the same command, streamlit run app.py, hit enter, and new browser will going to open. There you go. Now I'll click on start. There you go, we are getting the result on our screen, and you see how easy is it to do just calling few lines of code by just WebRTC streamer, creating a video processor class and processing the frame. That's it. So easy and straightforward, nothing much going on. But one thing I would like to talk at this point is the technology it is using is by the name itself, WebRTC, and for WebRTC there is a concept called ICE server. And for now, if I show you, RTC configuration is set to none, but for now on the local host it is running pretty fine. But when you deploy it on cloud, you need to define this RTC configuration. So for that we are going to import RTC configuration from Streamlit WebRTC, and you give it like this, RTC configuration. And in this there are some free ICE servers given to us. There is a concept of ICE. You can just learn the detail how WebRTC works. I'll just directly copy that. So this is the free ICE server given to us by Google. Actually, I'm also not much expert in how WebRTC work, but this is something you have to keep in mind. You have to give RTC configuration as like this if you want to deploy it on cloud. So this is the final code. Just you have to change these lines for your own use case for now, since we are just detecting the faces. In the upcoming videos, we will go much deeper in it, creating some video calling also by using Python and Streamlit WebRTC. You will see how easy is that to do all of that. And this is it for this video. I hope you have learned something new today. If you did, make sure to give this video a thumb up, and I'll see you in the upcoming video. Till then, keep coding and enjoy coding.